Welcome back to Factorio MSX Gigabase for our Marathon Tech Priced SpaceX Extreme. And we are doing the Extreme Science. Between our episodes, I actually finished up another one of the SpaceX Sciences. We now have both space assembly and space construction. Plus the fuel cells research, which is what we finished up between times. We're currently working on astrometrics because that will knock off the most expensive in terms of numbers of components, given that it uses all the sciences except military science and all these other sort of the low-cost SpaceX sciences use a lesser number. They don't use space science, so we're knocking that one off, and then we're going to concentrate on the purple sciences, so that we can start doing a bit of module efficiency, effectivity, whatever they're called. What are they called? Effectivity, efficiency, the efficiency modules, so that we can build the efficiency modules for our SpaceX components. In this case, the assembly robot, which is essential for dry dock assembly components. Now, what I am thinking of doing is, well, first of all, let's have a bit of a look at this area. Let's do it under InfiniZoom. And it's not a bad area. We could always nuke a little bit of this. I think I've got 10 nukes. So that could be a little bit of fun to start off with. Let's see. Close. Oh no, we've got the wrong weapon. There we go. That's the right weapon. Watched a nuke from this distance before. Hard to tell just how far it's going to go. There you go. Nukes as though they're from orbit. Okay, so there's a nice big spot here. If we really need to, we can landfill that. What we need to do is, I think I kind of sort of this guy, but maybe straighten this up in terms of you know, having some stackers at the entranceway. We don't really need the stackers on the exit though, and multiple inputs. I've done a little bit of some sums between times, because if you remember, we went back to the make everything to kind of see what we needed. So I laid out this pattern of so the robot frames, the construction robots, the assembly robots, and the other thing that would be missing would be robo ports. So we probably need all of those things, and I noted kind of how many machines we were going to need of each. So we can do a sort of 6-row by 11 spaced manufacturer module for the construction robots, which would basically take as input everything needed for flying robots, and then that would also be supplemented by what we need, the extra electronic circuits to finish off, and we needed electronic circuits anyway for the flying robots, so finishing off the construction robots with a few extra electronic circuits shouldn't be too big a problem. But we obviously can't do this while Astrometrics is ticking over. That's our only issue. So we'd need a lot of electronic circuits, so they'd need a dedicated line. Electric engines and steel could probably manage on a single line. How many of these are we actually building a minute? I think those two could manage on a single line. It doesn't actually matter. We don't have to run this at the absolute maximum ramp, but yeah, I mean, for argument's sake, to save one platform, it's probably worthwhile. We'll see how it goes. So 3 platforms plus an exit platform for the flying robot frames, and then that can feed into I mean, we could basically do the rest in a single installation, but the roboports, they need an awful lot of stuff. $45, so it's basically 9 every second, or 108. I suppose it's not actually that much. 108 every minute, and then we're multiplying that by 11, so it's just over 1,000 of each of those resources a minute. The thing is, though, if we combine roboports with the final, well, assembly robots, we're bringing in a whole bunch of things that we don't need for the assembly robots. So I'm not entirely sure how much sense that makes. Maybe it's fine, maybe it's not. I mean, just to save space seems to be a kind of pointless reason to build a particular way. We don't need that many machines, but that doesn't mean it can't be in a separate module. We only need 11 machines. One row of 11. And then the assembly machines and the actual structural components, the assembly robots, we don't need that many machines, but we would need low density structures, which we need here as well, plus modules, which could all go into one slot. So if this was all combined, we would have modules, low density structures, processing units, assembly robots, roboports, and solar. We'd actually have 6 lanes of inputs, which seems a little crazy, but maybe it's not, because we can sort of design this outside in, have all the lanes on the outside and the processing in the middle, which would look a little bit different, but it would be fine. So maybe that's what we'll try and do. Okay, I don't know if any of that makes sense, so let me try and explain out here. We have our bots. Good. Let's clear away some trees. I'm kind of thinking what I will do is put in a T-junction just here. Like, well, let's get rid of all of that. Where's my book? There's my book. So basically that. Then here we need some level of pre-stack for our first one, which was the construction robots. Construction robots needing, well, there's 4 things that can possibly be input, so maybe a 4 pre-stack kind of thing would suffice. So we could run straight into one of these, and we need basically 4 rows. Where's something that has 4 rows? That actually does. So I could, because you have this one plus these 3, so that would actually probably work for me. Let's just quickly grab a copy of that. We don't need those corners. I don't want that bit. I don't want that bit. Tick, map, rotate, and whack. Now this should be long enough for a 383 to fit. We can certainly check that we haven't lost anything in the translation. No, we fit easily. I don't know that I need those storage boxes. What's the problem? No problem. Very good. Okay, let's come out here. How far along does that go? Okay, and then we have our module here, and it feeds directly into another module out this way. Sort of the idea. So if we had an 11, we find an example of an 11. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. That's perfect. So let's get a blueprint of that. Maybe do the whole thing actually. Oh, it's not actually quite going to work. So something like this, but we need more paths. You need to go up like so. 1, 2. do we have to have it like that? Maybe just angle rather than a full bend. So that we can have sort of 4, and that's why I really only needed half of this, not the whole thing. Alright, never mind. If it was about there, let's just get rid of all of that and that. So no, that's not going to work. Okay. This looks a bit messy actually. I'm not really sure that I am comfortable with it, because they all should look like that. This shouldn't really be like that. So I think if I move this whole thing over a bit, it would be a lot better. We could push this back a little. That might achieve the same purpose. So if you're back here, and if we have, so one there and one there, that works, but there's not enough room up here for it to get into this lane. Whereas these ones can actually turn together. In fact, if this one if it came from here, so we can get 3 from there exiting okay. But if we came up another one, we would have trouble. which means we're going to lose a small amount of efficiency over what I was after. But something like this could be made to work. And you would go there. And then the fourth row go to wherever it needs to with a train that simply can go backwards and forwards from here. And then the other half of this, which quite frankly, instead of using that, I am just going to copy that lot and for now we will just reverse it over. Oh. Oh, what's the problem now? There. So, that is basically how we are going to do one of the inputs. So something like that. Then we can have robo ports up here, which just have to be far enough away so they can have their own stacker system like this. Let's grab some robo ports off the train. In fact, let's grab a few in case my bots decide to get clever and start laying them down in this area. Which in fact I want to slightly encourage, at least a few. So we want to get to a point where they're disconnected, which is there as a minimum. And that's okay, because for roboports, if you remember, we worked out just before that we don't actually need that many. We only need 11 in total, 11 machines in total, which is simply one row. Or I could do 5 and 6, but roboports have a very expensive little, well, they don't actually have that expensive a formula we worked out as well, but we might as well have sort of 3 lines coming in, and we don't even need that really. It's not quite as simple as I'm saying, because we are going to need to make the iron gear wheels locally. So there is that. I think I could have a just 3, but maybe I want to just copy this for simplicity. Since we've just done it. To that point. Now, I don't want those machines, I don't want those, I don't want those. Oh, I could have probably, doesn't matter. We'll work out those bits later. I don't want those either for the moment. Alright, so this is basically what we do want. And it can hook up with that one, except that it can't. Of course, it cannot. Alright, never mind. We'll just get rid of you. Now, there we go. So that's the minimum the rails will allow me to build our second such depot in. And we don't actually need an intersection like this. We can just put a normal corner piece in. Like so. Oops, not like so. Not at all like so. Let's try that again. There we go. I don't actually want that post there. We're out of rail. Let's grab some more. What about signals? They look fine. Right. Just the rail then. And connect this up. So if we go to our map view, this one here will make construction robots, and this one here will make roboports. Now let's let our bots finish up. Let's throw a station at the end here. And this is to come together to make these guys with the interim step of these guys. And we don't actually need that many machines when we get to those guys either, because it is simply over here. 9 of the assembly robots and 1, so it's just one little row really. One little row. Alright, let me copy this row. Because this is going to be for the roboports. Now, the other thing that we need here for making roboports, of course, is, as we said, the gears. Now, if we need 45 times... where are they again? Over here. So there's 11 of them. 11 times... let's get our formula. So it needs 45 iron gear wheels per 5 seconds, so times 45 times 12, that's 5,940 times the speed of the machines, which is 11.25 times 11.25. That means we need about 66,825. Holy jeepers. If we're really going to make... I don't know if we're going to be doing that. Have I made a mistake there? 66,000 copper cable, iron gear wheels per minute. How fast do roboports make again? Every 5 seconds. Wow. Okay. That's a lot of resources. We probably don't actually need to make them at quite this pace, though. So if we're making these guys at the rate we are, we're getting about 6,000 of those, which means we're getting about 3,000, which means we get 600 of these. 600 of those means we are getting 3/4 of an assembly, of the required number of assembly robots per minute. So that would be, we would need 120 of the roboports per minute to keep up with that. So 120 roboports times 45 gear wheels, that's 5,400. That makes more sense per minute. So what do we actually get? We get 120 from each machine unsped up, which implies 45 unsped up machines. Gears, they allow, they have productivity, so 45 divided by 1.4 is 32. And divided by 8 is 4. Basically 4. We only need 4 of those machines. Phew. That was starting to get me a little bit concerned, but obviously I was doing something a little bit wrong. 1, 2, 3, 4. Something like that. Then our connection to make the other part could be something like that. So got robots coming in, construction robots, we've got robo ports coming in. We need modules. We need low density structures. And we need processing units and solar panels. Processing units. Oh, that's right. This is why we were going to put processing in the middle and actually surround it, because we've got so many, because we don't even have the exit at this point for our product. Right, so that doesn't work. 1, 2, 3, 4, 5. Let's just get rid of those two for the moment. Now, if we had a row of roboports there, we could don't think I need that at the moment. We could fit in some processing along here, so let's check those numbers yet again, because my mind is like a sieve. So we need 9 machines making the assembly robots, and we need 1 machine, so it's basically 10. Yeah, it's basically a row of 10. Which I guess would imply something like this. Should mean I'd have to remove 2 more layers of these. Like, let's get rid of the lot. So something like 10 like that. What sort of range do we have? So we could either come right up close, which is probably not a bad idea. Oops. We don't actually need corners, guys. So this is for the end product, which will just be a very small train. That, for example, is modules. Yeah, like modules. Is that the right modules? Yes, it is. Low density structures. That covers everything there. Processing units. Actually, no, we probably do need to do it like this. So processing units. And solar panels. I think that is everything. One last check to make those. We need construction robots, which come in here. We need low density structures, which we have here. We need modules, red and blue and green, which come in here. That's everything for that. For these, we need processing units, we need low density structures, we need assembly robots, which are getting built here and here. We need roboports, which come in here. And we need solar panels, which come in here. Yes, I think that is it now. Does that reach far enough? No, of course not. But it actually does not matter. There's no reason why we can't have roboports up here as well. Like so. Yeah, I think I am going to leave our design here. We'll finish this, I guess, next episode, as well as probably finish astrometrics. Looks like we've kicked off launches again. Let's just have a quick look at the rocket silo, because that's very cool. Yes, it's loading up a train. There are no others waiting. 24 and 32, so we'll probably get up to actually it's hard to say exactly where it's going to get to. That's going to take another 15. These numbers are very low, so it's basically 15 off these ones. 32, 22, 54, so it's sort of at about 40. Another 48 iterations times 4, so it's about another 200, so 25, 4, 40 or so, something like that, to finish astrometrics. Unless another one of these trains gets called, which you never know, it might. How is science going? 12k, 12k, 6k, 6K, jumping around slightly. What about over 10 minutes? Well, those two have consumed the right amount. Oh yes, they have. So we have been doing our 12K SpaceX science a minute for 10 minutes. An hour, it won't be this, because it's a slightly different combination that we're using here. It should work for the red and green though. If we check over an hour, 720, but allowing time for swapping over the sciences, that's probably fair enough. So yeah, that's how things are going. That's how this lot looks. Looks like we probably need a supply station as well as stackers over here, but there's room. It doesn't look like this water feature is going to be an issue. All good. Thanks for joining me for this one. I look forward to seeing you in the next. Bye bye for now.